In this lesson, we begin to look at grading, that is, the process that DaVinci is primarily designed for. We'll start with technical grading, the so-called primary corrections. Using them, our goal will be to achieve the best possible fit or balance among our source clips. We are in the color panel and see our three working clips on the timeline in the storyboard mode. Our material was filmed using a Blackmagic 4K camera in the film mode. Since this is not the standard log familiar from film material, Blackmagic also supplies DaVinci Resolve with its LUT tables specifically for this camera type and this color space. They ensure the transfer of this film space into the standard linear space Rec. 709. Thus, we have two options. We either apply our source clip LUT table in the beginning, which means we'll be grading in the linear Rec. 709 space, or we apply the LUT table at the end, working with the source clip in the film mode. We would then likely use additional primary corrections tools, intended more for logarithmic grading. With this being a basic tutorial, let's select the first option and focus on grading in linear space. Therefore, we apply the LUT table in the beginning at the very first node. We'll discuss LUT tables in more detail later, but for now, let's just call up the menu with a right-click and, from the 3D LUT table group, select the LUT for Blackmagic 4K camera. I will name the node right away. As I have mentioned before, for clarity and the option to switch corrections on and off, it's good to divide the corrections into several nodes. Therefore, I'll create a different node for the next correction. We could make corrections just by guesstimating, of course, but if we want to make sure that they are technically correct, we should use DaVinci Resolve's diagnostic tools, so-called Vectorscopes. They are not automatically displayed in the color panel, so we need to select them from the menu. DaVinci Resolve offers four monitoring views: waveform, RGB parade, Vectorscope, and histogram. Video signal consists of three color components: red, green, and blue. Colorful image is then achieved by mixing the three. RGB parade displays each color component separately. It displays image from one side to the other, so what we see on the left, this tree for example, we also see on the left in the graph. The tree is composed of darker colors, therefore the graph curve is displayed at the bottom. As a rule, in the graph dark colors are displayed at the bottom, while light colors are displayed at the top. If we continue on, we see that here further to the left, there should be a light spot in the image. From the picture we see that it's a cloud. In the graph, the light parts continue to the right, but there aren't other clouds at this spot in the sky. That means it's these almost white little columns. RGB parade does not indicate how high in the picture the place is located. It only tells us its position in the left-right direction. We can check this also by flipping the picture horizontally and see that positions have changed. What was left is now right, both in the picture and in the graph. If, however, we flip the picture vertically, the graph remains unchanged, since it does not take into account the position's height in the picture. So, from the graph we can tell that this part represents the sky, this one light grass, and this one the darker grass. In primary grading, the most important factor is to have the black area in one location across all graph images and that it be truly black. The same goes for the white area, of course. So let's see how our first clip looks. We'll begin with black color balancing. At a first glance, the black, on this tree for instance, seems alright. But when we look at the graph, we notice that, in fact, it is not totally black. Its values are not approaching a complete zero, especially in the red and the green channels. The blue channel does almost reach zero. So first, we'll balance the channels. We'll be using the Lift tool. It offers several view options. The setting can also be adjusted in the Color Wheels panel by moving the marker toward blue color with the wheel. This button is for Reset, or we can switch into the primary mode and adjust the blue channel there. It's a minute adjustment, so let's do this carefully. When the channels are balanced, we determine their common value. If we want the picture to have as maximum contrast, we'll move them as close to zero as possible. This is more or less also an artistic decision, and sometimes the black can be left higher, or it can be moved much lower, so that even the darker gray spots become totally black. In our case, however, we will try as much as we can to approach the zero value. We can do so in the Color Wheels panel, using this controller. Or in the primary panel by adjusting the brightness component labeled with the letter Y. If unsure, the values can be checked using the cursor. If we switch on the RGB value display for the cursor, we'll be able to find the place in the picture where all values equal zero. Let's move on to balancing white color. We can use this cloud, for example. In the graph, we see that the blue channel value lags behind the red and green channel values. This can be verified using the cursor. For white color, we'll use the gain controller. So let's adjust the blue channel to the levels of the other two. Here again, it's only a slight adjustment. When the white color balance is complete, its value can be raised to the top of the graph's edge, whereby we achieve the maximum contrast without distorting the picture. Next is the mid-tone adjustment. Here we'll use the gamma controller. At this point we rely more on feelings rather than the graph. The picture should match the overall atmosphere and should seem natural. The mid-tones can also be adjusted in two ways. If we use brightness control, the letter Y, color saturation remains unchanged. If we use this controller, brightness will affect color saturation as well. The difference is not large, but I did want to let you know about it. The midtones are also the best choice when changing the clip atmosphere, that is, when we intend for the picture to be warmer or colder. A more dramatic midtone adjustment may also lead to shifting the lift and gain correction, which means that the values should be rechecked and tweaked if necessary. When finished with balancing, we can name the node. The next step should be picture saturation adjustment. So I'll add another node and name it. Let's set the picture saturation. I think in this case, I'll lower it a little. That completes our primary corrections. It's only up to you which of the video scopes you'll use for grading. Let's go over the remaining graphs. Waveform sort of mixes all three RGB parade channels into one graph. In the settings, we can turn on and off individual channels and compare them with RGB parade. We see that they are identical. In waveform, the places where individual channels intersect are easily identified. Logically, these places are white, since in the graph all the components are summed up. Vectorscope indicates color saturation, so if I make a picture black and white, we will not see a thing. With Vectorscope we can determine which colors are used in the picture. Blue and cyan colors are displayed in this direction, which means that the sky is somewhere in the middle. On the other hand, our roof is approximately somewhere here. Vectorscope is often used to fine-tune skin color as well for overall picture calibration by means of color strips. That is why it contains these calibration markers. If we insert the color strips into the timeline, we see that they are placed precisely into their assigned markers, which means that our picture is accurately calibrated. If an image with irregular colors showed up in grading but contained color strips, like these for instance, we'd know right away that something was wrong with it since the strips are outside of the assigned markers. Histogram does not indicate position within picture, rather it shows channel value distribution for our clip. For instance, from the blue channel we can determine that the clip contains a lot of light blue tones, the sky of course, and also many dark blue tones, which combined with the green channel represent dark sections of trees. Blue color is not represented much in the middle, which is also visible in the picture, where the midtones represent mostly grass or the roof. Let's move to the next shot. I'll show you a way to copy a grade from one clip onto any other clip. Just select the clip where grading should be applied. Using the mouse, move to the clip whose grade you wish to copy and press the middle mouse button. This way you don't have to create nodes repeatedly, just adjust them for this new clip. Fine-tune the lift. Now fine-tune gain. When it comes to midtones, we'd like to achieve a visual fit across consecutive images. Therefore, visually adjust gamma so that a clip change looks natural. Next, let's copy the grade onto another clip. We see here that the corrections need a more significant adjustment. This image was exposed differently than the previous ones. Therefore, we adjust lift, then gain. The hair shows an extremely bright spot, caused by strong sunlight. To adjust this spot, the 3 points, lift, gamma, and gain, are insufficient. We'd like to make another correction between points gamma and gain. For such an adjustment, we use curves. In order to keep the midtones, we create a point by clicking on the middle of the curve. Next, create another point at the top of the curve. Move this point slightly lower and make a correction in light tones. The hair thus gets more textural in the image. As we see, beside brightness, the correction is applied onto all color channels. If a color channel needs to be adjusted individually, select the Gang Custom Curves option. If you wish to remove a point from the curve, do so with a right click of the mouse. The curves can obviously be combined with lift, gamma, and gain corrections. So if we wish to move the midtones, for example, it can be done through the gamma controller. The resulting correction is a combination of all other corrections. In this lesson, we went over primary corrections, the lift, gamma, and gain settings, color saturation, work with Vectorscopes, and finally, the alternative color correction settings using curves.